So, so the overview kind of today is that we want to kind of talk about how to design a database from scratch, and especially talk about how to use this tool called an ERD to design it. So that's kind of the focus for today. The first thing I want to do, though, is kind of show a video because it gives a really good explanation of kind of what a database is and why they're important from a business perspective, and basically comparing it with, well, most businesses have spreadsheets, or they start doing their business with spreadsheets, and then eventually they kind of grow out of that. And what are the why would they want to go from maybe a spreadsheet to a full-blown database? So that's kind of the first piece here. If you do want to watch this video back later, I've put it up on perusal as one of your assignments for this week. So I'm just going to play that through here. It's about 8 minutes long, so it's pretty short, and then we can discuss it afterward. So questions?
Nope, but I like him. I'm sold. But give me a database. He could sell me my car.
It's a good video, I'd say, because where we're at right now, it just seems like an Excel or something really small is more than capable to accomplish what we need. But if we're going to be hireable for, especially a tech giant, they're going to need something of that size to handle it. So we need to at least understand that concept.
Yeah. So, I mean, all the things he listed, that's kind of where the combination of your database and your web application come together, is those two things together kind of provide all those pieces.
So, the concepts he was talking about, like size and structure and all that, importance. With MySQL, what does MySQL cover with those?
Really all of them. I would say in general, most relational databases are able to address all of those things.
Okay.
With relational databases, generally all of those things are kind of out of the box. You get them. Or most of them, you get most of them pretty much out of the box. The one that you usually have to implement yourself is he kind of talking about needing to track every change. That's usually something you have to kind of build into the system using something called a trigger to make sure all those changes are saved. With NoSQL databases, which we'll talk about in a few weeks, some of those aren't built in the database level. You kind of tack them on the application level, but that's helpful because you get more performance by doing it that way, if that makes sense. So part of the distinction between different databases is what can you do at the database level and what do you need to do at the application level. But you can always get all of those things regardless of what database you're using on the back end by putting a web application in front of it.
Okay.
Okay. So let's talk a little bit about some of the theory here. I've got the recording going already, so this will all be recorded and I'll get it posted at the end of class. So let's talk about how we design databases. We just talked about why we want databases, right? From the business perspective, but we need to talk about how do we actually build them. So I want to talk about terminology real quick first. We've covered some of these terms already, but I want to make sure that you're familiar and you've got kind of a definition for each of these terms. So when we're talking about relational databases, you'll hear the term schema thrown out a lot, and that refers to the collection of SQL statements that we need to define our database. If you read through one of the reading assignments yesterday, you'll remember that schema is generally composed of your DDL, your data definition language, right? So you may have some schema manipulation language, some data manipulation languages. You may have some DML in there, but it's mostly going to be your DDL is what we're referring to as your schema. So that includes things like the instructions to create the database, create the individual tables, and add all sorts of constraints and indexes and views and whatever else you need to add to the system. Okay, so that usually ends up boiling into, you can kind of put it into one script to define the entire schema of the database. And so there's some value in doing that so you can replicate it to other servers and things like that. Next up, we've got the database, which is kind of the implementation of that. You can think of the schema as kind of the class, right? The instructions to build it and the constraints that are applied to it. And then the database is the actual data, the actual object, right? So you can think of it as class and object sort of thing. Okay, so the database is where you actually hold the data and such. Within that database, we're working with and talking about relational databases right now. So there are always going to be tables in that relational database. And so that table has constraints. We had to define the columns, and we may have to define, well, this column can only be a number, this column can be a string, or it can be a string that's 100 characters long at most, or 5 characters long at most. So we can define different constraints there. There's other ways. Additionally, we'll talk about like foreign keys and other more ad hoc constraints that you can actually add to the table as well. So it's not just the columns, but it's also the constraints. And then within that table, we then have our actual rows, our actual data. So when we're talking about table, we're kind of mixing two pieces. We're talking about the schema of that table, but we're also talking about the data in that table as well. When we're working with tables, remember we're defining those columns. So each column has to have a name, it has to have a data type, and then it may have constraints on it as well. You're always going to say, is this column required or not required? Does it allow null or does it not allow null? And you can also do things like with the columns, sometimes you need to specify a default value, and that default value is what will be put in there if you don't tell it. If you insert a row and you don't tell it what to put in that column, that's what it's going to use, is that default value. So there's a lot of things and a lot of attributes that your columns can take on. But at base, it's always name and data type. Those are kind of your minimum two pieces that you have to have. Then you get to your rows, which is pretty self-explanatory. Each row represents a single, what we say, data point or entry. Like if you're looking in a spreadsheet, it's that same kind of idea of a row, but that's how we store our data, is in rows. Oftentimes you also hear them referred to as entities. Entities is kind of the more general term that applies across all sorts of databases. Relational databases have rows, but not all databases have rows. So referring to things as entities is a little bit more general. And works with other databases as well. So you can think of that row or that entity as really as an object. The kind of things that we would create in C# and JavaScript as objects. You can think of those as your rows in the table. So if you've got a class, you can kind of map those classes to tables and then your objects to rows as we're mapping things. Next up, you'll hear the term cell or field. Cell is kind of that intersection between a row and a column. We'll oftentimes, again, refer to it as a field because that's a little bit more general. But when we're talking about that, we're saying, hey, that place where you actually hold the data, and it's got a name because it's part of a column. But what it holds is always going to be a single scalar value. Okay. Now, who can tell me what the term scalar means? You may have heard that term in math class.
What term?
Scalar. What is a scalar?
Isn't it used to define like space, like for like direction or something, or like it's a vector?
No. So that's actually what it's not. That's actually the opposite of a.
I tried.
Yeah. So a vector is generally direction plus an amount, and that amount is a scalar, actually. Usually a vector can be thought of as a combination of two scalars.
Okay.
Or in 2D or three scalars in 3D. Mo, you were saying something?
So like quantity.
Yes, like quantity would be a single, right? It would be a single value. Okay. So just to give some examples, let's say I have just a single number, that's a scalar value. True or false, that's a scalar value. But things that are not scalar would be things like I have a person object, right? A person object is not just one value. Okay. Or let's say I have an array of my pet's names, right? That may be anywhere from 0 values to, infinitely number of values. Maybe I have 20 pets, right? So that's not a single value. Does that make sense?
So it has to be like one-dimensional in a sense.
Yes. Well, not even one-dimensional. It's 0-dimensional. A scalar is 0-dimensional.
Okay.
If you're thinking about a number, it's a single number. If you're thinking about it means that you can't put things like an array in there. Basically, you can't put arrays and objects in there. Cool.
Yep.
So another term you'll hear thrown around, which isn't as obvious because it's not really part of the schema directly, but it's a very important part of relational databases, enough that it's actually in the name, is this idea of a relation or a relationship. And a relationship is a connection between two entities, or you can think of that between two objects, right? So how are things connected to each other? And that connection can take a lot of forms. It can take a form of, saying that something is part of this other thing. It can say that you are related to this other thing. Maybe you're, saying who your parent is or who your children are, or which courses you are part of, or who's teaching a course, or all sorts of things like that. What products have you purchased as part of an order? What roles is your user part of? So that relationship idea is probably one of the most important parts of actually thinking about and modeling our database. So when you're kind of looking at those terms and thinking about how to store your data, the most important things to pay attention to are the entities, the things, and the relationships. Okay? The most important two pieces are the entities and the relationships. And that's regardless of what kind of database system you end up building, as you're modeling it, the entities and the relationships are the most important pieces. Eventually in there, you have to kind of drill down and say, what fields do each of those entities have? But you want to start with, at kind of a broad scope, laying out the entities and the relationships before you get down to talking about the fields, which is kind of one of those mistakes that people make a lot of times. They'll start writing the entities and the fields before they even start thinking about the relationships, and that means that you have to do a lot of rework, and maybe you're missing something important because you haven't thought of those relationships yet. Okay. Any questions on that term relationship at this point, or any of those other terms?
Nope.
Okay, so let's talk about how to design our or diagram our databases. Okay, so what we're going to go through in this next part is something called an entity relationship diagram, and we usually shorthand that as an ERD. So an ERD is really a vital tool for discussing your entities and your relationships in your data with your customers, with your stakeholders, and with developers. It's a really, really important communication tool to make sure that everybody's on the same page about what is the data that your application cares about, and how to really model the data and the connections between the different parts of the data, because it's kind of the foundation of everything built on top of it. Once you get to an agreement on what the data is and how you need to store it, then you can start building both the back end for it and the front end for it, because you know, okay, this is the data we're going to have and how it's kind of going to be structured. So I would really stress that it's important to build your ERD before doing any coding. Before doing any coding for your web application, you should definitely build your ERD, because it will save you a lot of time in the long run, where you'll work out some of those kinks that you're going to have with your application before you get into, hey, we have an application that has some major flaws or doesn't necessarily meet the client's needs. And then it's going to require a lot of rework, and maybe there's a lot of lost man hours because you didn't do that design up ahead of time. So there's kind of in the industry, there's been a lot of, especially with Agile, there's been a lot of kind of pushback and thought of like, well, maybe maybe we don't need to do as much design in the front end. Really what was intended with that, with Agile, was to say, well, let's do less documentation. Let's not try to design the full system up in front, but it doesn't mean we don't do any design, right? We just have kind of limited how much of that excess design we do. ERD still has a place in Agile in terms of a way of communicating design. So the thing I'd stress again is make sure you do this diagram before you start the code. If you jump into the web application first and then try to work yourself back and then build the diagram later, which sometimes I see people doing, you're not going to get the value of the ERD. The value of the ERD is in building it before you build the code. If you make the ERD after you write the code, the ERD has no value. Cool?
Yep.
Yep.
Okay. So there's a bunch of different ways to make this ERD diagram, and in fact, there's not one standard way to write them or design them. There's at least 3 or 4 different competing ways to do this. So just keep that in mind if you're looking at different tutorials online or different tooling to do it. You're going to see that they take slightly different tactics for how they document these and write these. Okay. In terms of tools that you can use to create them, there's always your good old-fashioned pencil and paper. These can actually be fairly easily created and written on paper or with a whiteboard, and sometimes that's the easiest place to start, by just laying out your laying out your entities and your relationships. Now, I would say as soon as you get to, you have those two parts figured out, your entity and relationship, that's where paper and pencil becomes kind of obsolete and not very helpful. Once you start looking at, well, what fields do each of these entities need to have, then you need to move to some sort of digital application to really be able to track all of the data. So you can write this in paper and pencil. I would recommend that only as a starting point. It's a quick starting point to get your basic things figured out. But then I would move on to an actual application to do the rest of it. So different tools you can use from there. Google Docs. There's drawing tools and diagramming tools in there that will let you make flowcharts, and in most diagrams, that can oftentimes be sufficient for making an ERD. So that's one way you can go through. There's also several different applications out there, websites out there that you can use to build these as well. So let me go through some of these and just show you what's available. These are this is by no means an exhaustive list, but these are just some applications that I've seen out there and are good choices for this tooling. So the first one up is SQLDBM.com, and I'd say really of this list, I think they're really the best one I've seen. So I definitely take a look at them. They are really built well to handle a lot of different relational databases at this point. They've got things set up where you could do SQL Server, MySQL, Postgres, etc. That being said, some of the tools like this are maybe a little bit restrictive in terms of because there's constraints and stuff put on it, and it's trying to be closer to your SQL, it may be limited in terms of not necessarily working with all databases, right? And this tool may not work so well once we start talking about MongoDB, because kind of the way you model NoSQL databases versus SQL databases is a little bit different. So there are tools and techniques that work well for both, but some of these tools are specifically designed for sort of SQL databases, and this is one of them. Okay, so that's one tool you can use. I think that's the one I'd really push you towards. This is a free tool. The next one on my list would be dbdiagram.io. This one's not hard to use either. Basically, it's got its own language, which you'll kind of see here in the preview on the left. So it's got its own sort of language for designing the database, and then it creates the diagram for you. So that's another tool that you can use, and this is completely free as well. Other tools that exist, Umlet is one tool that I find really good for UML and doing UML diagrams, which UML diagrams also function decently for creating ERDs. You'll need to we'll talk about the cardinalities a little bit. They do their cardinalities a little bit different than we might normally do, which what I'll go over today is crow's foot notation. So you'll need to know how to do those cardinalities different, but this is a good tool for doing that if you're going to do it as a UML class diagram type thing. Another option that's related to that, Umletino, is just an online version of the same thing. So Umlet is an application that you download and run on your desktop. Umletino is the same thing, but it's in the cloud. So you can do that in your browser instead of downloading it. And then finally on my list is Lucidchart. They have some diagramming tools. They're free but they are at least free to register, but they do have some limits on what you actually get for free. And I think their limit are somewhere between 1 and 3 diagrams has historically been their limit to how many diagrams you can create for free. From my perspective, it's not necessarily that Lucidchart is a bad tool. I don't accept them because I've had some issues with students in the past using it. So I don't accept any diagrams using Lucidchart anymore. If you give me a chart with Lucidchart, I'm going to ask you to redo it in another application. Cool?
Cool.
So there's a lot of different tools out there. They all kind of take a different approach to this. So take what we're gonna do in these slides with a little bit of a grain of salt, because your particular application that you choose to use may diagram it in a different way. Okay, so let's get into how we create ERD diagrams. So the first and most important part of your ERD diagram is your entities. And your entities represent your objects and your things in the application. Okay, we generally represent them as square or rectangular boxes with the name of the thing in there. And we're generally going to do those as their singular form. So we're going to say, hey, we have got courses. Like if I've got courses, I'm going to call this course. I've got students, I'm going to call it student. And we use the singular form generally on our ERDs, regardless of what the actual name of the table ends up being. So we could call the table courses, we call the table course, but we're going to, on our ERD, use the singular form. Okay. So here I have, but that's usually the way I would recommend it, but it doesn't have to be that way. You can use plural, you can use singular. But the way I'm going to do this is using the singular form. So let's say here we have an application, right, that is tracking online courses, right? So you've got courses, you've got students, you've got teachers, you maybe have users. So those are some of the common entities that you might see in some sort of online course system. What's another common entity that you might see in here?
What happened? You cut out.
Huh?
You cut out for me. I didn't hear it.
What is another common entity that you might see in a system like this, where you're trying to deliver online courses?
Maybe a URL.
We're talking about things. So a URL might be a property of something, but it wouldn't be a thing, typically.
Books.
Books? Okay. So like if your course has multiple books, right, you need to may have that as a separate entity. What about lectures, right? You might need an entity for lectures, right? If I ask you to do some work, right, what kind of work might I assign?
Online.
Homework alert.
Homework? What else?
Reading.
Reading? Okay.
A test.
A test, right? Might have a test. What else?
Labs.
Maybe labs. So all of those kind of things could be an entity in our system, right? We could have entities for tests. We could have entities for labs. The important thing to keep straight, though, is it has to be a thing. So like you were mentioning a URL wouldn't count because it's just a single scalar value. It needs to be something that's an object that would have more than one property, if that makes sense. Okay, so course, student, teacher, user. Okay, the next component that we'll add to our diagram is going to be the relationships between those entities. So for instance, if we're talking about this system here, we might have, well, there's a relationship between students and courses in the fact that students take or study courses, right? Or they participate in courses. So we'll denote that with a diamond here that connects those two things. So a student studies a course, right? So they're connected, right? Because you want to know who is enrolled in your course. Similarly, we might have a relationship between teachers and courses because a teacher needs to teach a course. Okay, so your relationships are your connections between entities. Any questions on relationships?
Nope.
Okay. So once we've got, I would say when you're building your ERDs, definitely start with these two things first because they really are the most important thing. Put in your entities, put in your relationships, and then sit back and look and see if you've missed anything. And I would strongly advise you get this far, send it to me, and let's talk about it and see if there's anything missing in your system, because you can, at this point, you can often tell if it's even just with these two pieces in place, you can usually tell if it's a good design or if it's a bad design, just by looking at kind of where that's oriented. Okay. Now, the next thing you want to do once you've defined what the relationships are is you want to look at how many things are kind of in that relationship. What types of relationships do you have? And the term that we use for that is called the cardinality. And that's generally the term we use when we're talking about ERDs. Now, if you're looking at documentation and you're doing these as maybe UML diagrams, which you can do as well, UML talks about this in terms of multiplicity. Multiplicity is their name for this. So multiplicity and cardinality, you may hear both of those terms. They mean the same thing. So your cardinality is how many things are connected to each other, right? So if we're looking at between teachers and courses, we know that, well, every course normally, right, how many teachers usually teach a course?
One.
It's usually one, right? You could have a case where you have 2 or 3 teachers teaching the same course, but usually it's just one teacher per course, right? Now, how many courses can a teacher teach?
Teach more than one thing.
A lot.
They can teach a lot, right? Or we could say more formally, they can teach many, right? So one teacher can teach many courses, but each course is only taught by one teacher. So when we're looking at the cardinalities, we need to ask both of those questions. So we go this direction, we say the teacher to the course, what's the connection there? How many courses can a teacher teach? And that's where on this end, I'm denoting this with what we would call a crow's foot. So this denotes that there are many courses taught by the teacher, versus this side, you see there's a little hash that represents one. So this would be a case where you have a one to many relationship. Okay. In general, our relationships will boil down into one of 3 options. It will either be a one-to-one relationship where there's always one thing connected to another thing, and there's never more than one on both sides. These are a little bit rare because oftentimes if it's a one-to-one relationship, you can usually take those 2 objects and make them the same object. There are some values and places where you may want to have those things split up as separate objects, but oftentimes if it's a one-to-one, you can end up merging those 2 objects together, those 2 entities into one, because they kind of end up being one and the same. One to many is then the most common one that we see. And that's kind of like where you see teachers and courses. There's one teacher for every course, but a teacher can have multiple courses. If I was saying this was one-to-one, I would be saying every course is one teacher, and every teacher only has one course, right? Which I could build a system like that, right? I could build a system where teachers can only teach one course, right? But maybe that wouldn't make a lot of sense, right? Because effectively I'd have to kind of maybe delete courses over time, and I might have to or continually update that course. So the kind of relationship that you choose here can have a very big impact on your end users. Okay, it can have a very big impact on your user. So one of the things we've already ingrained in here, if I choose this relationship between teachers and course being one to many, I can't then go build a system that allows a course to have multiple teachers. You get that?
Yeah.
So if I need that, if for some reason, I have that requirement that may happen in the future, even if it isn't happening today, that's something I need to bake into the system early. Because relationships, these cardinalities tend to be hard to change later on in your development cycle. These are things that you have some control over at the beginning, but once you start building the system, it's really hard to change the cardinality of a relationship. Okay, and that's why I say this is probably one of those things that you want to think about first, because it will save you time down the road. Okay, so things can be one-to-one, things can be one-to-many, or they can also be many-to-many. Okay, which is what's happening with our students and our courses. And we can think about this, all of these relationships, and figure out what kind of relationship it is by asking two questions. And the first question is looking basically from left to right, and the other one's from right to left, right? So if I look at students to courses, right, how many courses can a student be part of?
Many.
Also good.
So that's why I've got this crow's foot over here. I'm saying that the student can be part of many courses, right? Well, how many students can be part of a course?
Many.
Many, right? So that's where I get this one. How many students can belong to a course? Well, that's also many, right? So here I have a many-to-many relationship between students and courses. So as you're doing this, you have to think of it in both directions. Questions?
Nope.
Okay. So if I were to add in to this diagram, let's say I were to add in lectures, okay? What entity would lectures be connected to? Would it be related to?
Course.
Probably the course, right? So the lecture would be related to the course. What might I call that relationship?
Many to many.
Probably one to many. One course
has multiple lectures, right?
Oh,
One course has multiple lectures. If I said it was many to many, what does that mean? Because that means something more.
A course could have multiple lectures, and a lecture could be to multiple courses.
Right. So if it's many to many, then not only can a course have multiple lectures, I can also put that lecture into that same lecture into multiple courses. If I say one to many, then that lecture can only be part of one course, right? It can only be part of one course. Many to many means that that lecture can be part of multiple courses. So both of those can exist, and it depends on this kind of system you're building, right? So in general, many to many is more flexible than one to many, but it does mean building out a lot more logic. One to many connections or relationships are generally simpler and more restrictive systems, whereas if you have a many-to-many relationship, it usually ends up being a more complicated system. Does that make sense?
Yeah.
So as you're kind of building these out and thinking about complexity and how hard is this going to be to build, you may want to pay attention to those kind of things. So obviously there's certain features you can't implement if you're doing one to many instead of many to many, but it can also make your system a lot simpler. Okay. So it's worth paying attention to those, because that will have, again, a big impact on your code, whether it's a one-to-many relationship or a many-to-many relationship. And you'll notice that the one-to-many is directional, right? It's one teacher to many courses. If I flip this over, right, if I put the crow's feet over here and the one over here, is that the same thing? It's not, right? If I say, a course has many teachers, right, if this is one-to-many, then I'm saying that the course can have 3, 5, 10 teachers, but I'm saying that teacher can only ever teach one course. If I flip this around, then my teachers can only ever teach one course, and then they have to retire. Right? So that would be a problem, right? So when we're building this out, the direction of those really matters. And the way that we define that direction in code will be with something called a foreign key, which we'll talk about in a few slides. So where you put that foreign key determines the direction of this relationship. And if you get it wrong, well, then you have a system that's not usable, that doesn't make sense from a user's perspective. Okay, so we talked about entities, we talked about relationships. The next thing you'll want to add to your diagram is the attributes. And this is a place where you can still do this part on paper, but it might be worth moving to an actual digital solution when you start looking at these attributes. And there's more than one way to diagram these attributes. The way I'm showing here is with ellipses that are kind of connected to it. So that's one way to write it. The other way that sometimes people will write these ERDs is they'll turn the entity into sort of a table. So you'll have the name of the entity at the top, and then the attributes listed below. Okay, which is how several of those diagramming solutions work. Okay, but there's some value if you're doing this, especially on paper, or you're maybe thinking about this in terms of NoSQL, of diagramming it this way. So if I'm looking at the student, I need to say, what are the attributes? What are the properties of that thing? Right? So if I'm looking at the student, well, they might have a few different attributes. So common things you might see on the student might be they have an ID, right? So you have the student ID, you have their given name or their first name, and you have their family name, their last name, their email address, and maybe their date of birth, right? So these would be kind of common things that you might know about a student, right? You'd have more, you'd have less. There's no limit to how many attributes your entities can have. Okay. Now, one thing to remember as you're putting these attributes in, remember that they have to be scalars, right? Remember we talked about fields need to be scalar, because your attributes are going to map to fields in your database, right? Individual cells. So whatever you put in here needs to be something that you can answer with a single value. If you can't answer it with a single value, then that means that you need another entity, right? So if I'm trying to add in courses, right, I can't just put that in as the course name, right? I need some additional information, and that's where I would create another entity. Cool?
Yeah.
Okay. But I would stress, don't go to the attributes until you've fully figured out the relationships. Okay. So, now that we've kind of talked about the stuff you put in the ERD, it's worth talking a little bit about how do we then go take that ERD and we actually implement it, because there are some requirements when we go to turn it into an actual schema, into an actual database. And one of those requirements is that every entity must have a primary key. And this is a requirement basically regardless of what database you're using. Every entity needs to have a primary key. Okay. Now that primary key needs to satisfy 3 different requirements. Okay, so the first requirement is that its value must be fixed. It can't be a value that you're going to change later. So, for instance, if I'm looking at this student, if I say that my given name is my primary key, well, that means that they can never change their first name. Right? If I use my given name as the primary key with this fixed attribute, they can never change it. Similarly, if I use their email as the primary key, they can never change their email address. Right? Would that create some problems if you can't ever change your email address?
A little bit.
A little bit?
Suffering that problem right now.
Would that create some problem if you use your family name as the primary key?
Yeah.
Can family names change?
Yep.
When do they change?
Marriage,
right? So that would not be a good case. That would be one reason why we would knock out things like family name and email as not being valid primary keys, because they might be things that change. Similarly, if I'm talking about courses, right? Could the name of a course change?
Yep.
Yeah.
Right, it could.
Yeah.
So I wouldn't want to use the name of the course as its primary key, because that would prevent me from changing the name of the course. Okay. If you need to change the name of an entity, the only way to do it is to delete the entity and create a new entity. That is the only way to change the primary key, is you have to delete it and create a new one. So that's really important, that it's a value that does not ever change. And I mean, does not ever. Never, never, never should it change. The next requirement for that primary key is it has to be unique. You can't have 2 entities in the same table with the same primary key. Okay, you can't have 2 entities in the table with the same primary key. And that would knock out things like your given name, right? Your first name, there might be multiple Pauls in the database, right? So your given name might not be unique, right? Similarly with the family name, your family name's not unique. Multiple people can have the same last name, right? So that knocks out those 2. Same thing with date of birth, right? More than one person can be born on the same day, right? Yeah. So what does that leave in here of things that could be unique?
ID.
What else?
Maybe email.
Maybe email. Well, your email should probably be unique. I think you probably have a problem if 2 students have the same email address.
But they could change.
Huh?
Emails can change too. I guess if it's a school email, no. But personal emails, people might create a new one.
Right. So let's say it's a personal email. Let's assume it's a personal email. Email would fail for the first requirement, right? It would be fine for the unique requirement, but it fails the requirement that it needs to be fixed. Does that make sense?
Yeah.
So some of these fields can meet one or 2 of the 3 requirements without meeting all 3, but they need to meet all 3 to be usable as the primary key. Okay. So those are the first 2 requirements. It is worth noting that primary keys can be more than one column. Okay, your primary key doesn't have to be just one column. That's kind of the simple version of it, but your primary key can be a combination of columns, in which case we call it a composite primary key. So for instance, I could take your given name and your family name and say, well, those things two together, let's use that as your primary key, right? Well, where might that fall apart? It's going to fall about, again, with the fact that you may need to change your first or last name, right? So it still violates that requirement. But is your given name plus your family name, is those 2 things together unique?
I mean, it can be, but it can also be a generic name. Someone can have the last name, not to be mean, but Smith and Paul.
Yes.
There's 2 Pauls and there's multiple Smiths.
Exactly.
There's probably someone else named Paul Smith.
Right. Any place I go, anytime they're looking up for my information, there's always more than one Paul Smith. Always, right? So when you're designing your database, that edge case is not an edge case, okay? Because what you're saying is when you're defining constraints like this or you're defining primary keys, you are saying that that's something that can never happen. Does that make sense? So if it could ever happen, you need to design for it will happen. Does that make sense?
Yeah.
Okay. So that means that even if you might say, well, here's my business. I only got 100 customers, and none of them have the same first or last name pair. That doesn't mean I then go build the database around that, right? Because eventually that will happen, right? And if I code it that way, where with that expectation that they'll always be unique, the only way for me to really fix that, I'm going to have to do a major overhaul of that application. Changing a primary key is really not easy. Does that make sense?
Yeah.
It's a major problem if you need to change a primary key from one thing to another. So do keep that in mind. Okay, so you can have composite keys, but you need to have a combination of things that are then, still satisfy all of these requirements. So a primary key can be a single column, it may be multiple columns put together. Another requirement for primary keys is that can never contain nulls. Okay, they can never contain nulls. So things like maybe my telephone number is optional, right? Well, that wouldn't work because I can't have nulls as part of my primary key. That might also be a problem with email if you say, well, some students don't have an email address, right? Or we don't know the date of birth of all of our students, right? So null can't be a value there. So sometimes, we have data there and we can pick out one or two of those columns and maybe three of those columns, and that will be good for our primary key. But oftentimes we get into a place where we look at all the data we have, right? Let's say we just have those 4 columns here, the first name, last name, email, and DOB. Well, we're at a standstill. None of those 4 can be used as the primary key. Does that make sense?
Yeah.
So oftentimes we end up adding an arbitrary number to our entities, which we just call the ID, which is basically, for all intents and purposes, is randomly generated, right? It's not anything. That number does not exist in the real world. It's just something we come up with to give that entity a unique value, right? And that primary key would generally list as the first column in the table. Okay, so whatever is your primary key by convention, we'll put that at the beginning or the left of your table. It can be technically anywhere, but it does make the code a lot easier to read if you put that first. Okay, so if we're talking about course, I might call that the ID, or I might call that the course ID. Okay, there's kind of the 2 conventions in terms of naming that ID column. You can either name it just ID, which is okay because that column name is unique among a bunch within your table, or we'll sometimes add the name of the entity to it. Cool. So you can either call it ID or course ID. Both of those are valid choices. So we've put in primary keys. That's something that's required. We then also, to define the relationships, the way that we define and implement our relationships is using something called a foreign key, right? So a primary key uniquely identifies the entity itself. A foreign key gives us information about a relationship, okay? A foreign key gives us information about a relationship. So, for instance, as we talked about previously, remember a teacher can teach many courses, right? So you got a one-to-many relationship here. So to implement that relationship in a relational database, there isn't a way to just add this relationship in between. We have to implement that with a foreign key. And that foreign key will always be implemented as a column or a field on the many side. Okay, so I'll put it on the many side of the relationship. So on the course, I'm going to add a teacher ID column, which refers to, this is a foreign key, which refers to the primary key over in the teacher column, over in the teacher table. Does that make sense?
Yeah.
Yep.
So this is where the direction of your relationships is really important. If you put the foreign key on the other side, where if I say, let's put a course ID on the teacher, we're now saying that that teacher belongs to a course, right? And that would flip the direction of the relationship. Now, it's worth noting you generally can't put a foreign key on both sides. So I can't say teacher ID, course ID, teacher ID, course ID on both of these two things. That would get you into a whole lot of trouble. Okay, so your foreign key is only going to be on one of these two sides, not both. And it's always going to be on the many side. With the foreign key, so this is a teacher ID, right? So there has to be a teacher with that ID, right? So let's say my teacher ID is 3, right? And maybe we have a few different teachers in there is 1, 2, 3, 4, 5, right? I can't then go make a course with a teacher ID of 7 because we wouldn't know what teacher that goes with. There is no teacher 7. So a foreign key also implies a constraint. It implies a constraint that it has to be a value, it has to be a primary key found in another table. So it defines a relationship, but it also defines a constraint. So that means if I try to insert or update in the courses table, if I try to put data in there and it would have an invalid foreign key, I'm going to get an error when I try to do that. I'm going to get an error saying that the foreign key was violated, and it's going to prevent that operation. Another thing that means is, given that, okay, that teacher ID has to be there before I can put the course in there, right? So if I need this course to refer to teacher ID 7, can I put the course in before I put in teacher 7? No, right? So the teacher then has to exist in the system before I can add the course. Does that make sense? So it creates an ordering to these things. Is this which thing has to come first, right? So in this case, the teacher has to get into the database first before we can add the course, okay? Because we've got the foreign key that refers to it. Now, if I want to then, remember there are 3 different types of relationships, 3 different cardinalities. What are those 3 cardinalities?
1-to-1, 1-to-many, many-to-many.
Many. Okay. So in a one-to-many, obviously, as I've said, the foreign key has to be over here on the many side. Okay. What about the one-to-one side? Which side would I need to put the foreign key on?
Would it matter?
Yes and no.
They're kind of the same thing.
It's kind of the same thing. So if it's a one-to-one relationship, it doesn't necessarily matter. You can put it on either side and it may work. But remember, there's still that requirement with the foreign key that the other thing has to exist, right? This teacher has to exist before I can add a course, right? So if this was a one-to-one relationship, that still exists, right? So there's still that idea that you have to insert one before the other, right? So let's say I maybe have I have my login credentials for my users, and I have my users, right? And I've separated these as the two different tables, but it's a one-to-one relationship because every user has one set of like username and password login credentials, okay? Well, if I say the foreign key is on the credentials, which of those two entities has to get into the database first?
The user.
The user, right? If I put the foreign key on the user, which has to come first?
Credentials.
The credentials. So when I'm registering new accounts, right, what place I put the foreign key changes the code that I have to write. Does that make sense? Changes the order of the code. So in a one-to-one relationship, you can, in theory, put it both places, either place, but it does create an order. And the way I would say is usually the way you want to think about it is think about the whatever is the quote-unquote parent, that is the one, right? And whatever this child is the many side, is where you put the foreign key. Does that make sense? So you can think of these as kind of parent-child relationships. Wherever you have the foreign key, you're saying that record is kind of a part of the thing it's referring to, the thing it's related to. Okay. So what about many-to-many relationships? If I'm in a many-to-many relationship, where do I put the foreign key?
You could do both.
Okay. Let's walk through this. So if I said teachers to courses is a many-to-many relationship, what does that mean?
Teacher can have multiple courses, and a course can have multiple teachers.
Right. Okay. Okay. So that's my intent. That's my intent for a many-to-many relationship. But let's walk through what happens if I put the foreign key on both sides, right? So I say, here I've got a teacher ID, and here I've also got a course ID. Right? So now I'm saying that the teacher belongs to a course, right? The teacher belongs to a course, right?
Yeah.
So then how many course IDs can the teacher have?
One.
One, right? The teacher can only have one course. Which then, what's the relationship from teacher to course? Well, that would actually make this a 1, right? If I put the course ID, that effectively makes the teacher only ever part of one course. What happens if I then also have the teacher ID here? The teacher ID says that the course belongs to this teacher, right?
Yeah.
So by putting the teacher idea here, I'm actually saying that this course only belongs to one teacher. So if I put the foreign key on both sides, I'm saying that the course belongs to one teacher and the teacher belongs to one course. So what kind of relationship do I have?
Like a forced one-to-one?
A sort of one-to-one. Except that I can now have some data inconsistency, because I can have the course saying it belongs to teacher 7, but teacher 5 could belong to this course 3 or whatever. So they can disagree on who they belong to if you have the foreign key on both sides. Does that make sense?
Yeah.
So if you don't ever want to put a foreign key on both sides, because it opens you up to data inconsistency. You don't do a two-way relationship. So okay, so I can't do that, right? Well, let's think about that. Well, so what made this one-to-many? It was adding this teacher ID, right?
Yeah.
Right? So what happens if I leave the teacher ID out here and I just have the course ID and the teacher ID? What's the relationship now between the two?
One to one? Because you won't know what teacher goes to what course.
Okay, so we don't know what teacher goes with what course, which means there's what kind of relationship?
I don't know why, but my brain just says undefined.
You're right, actually, Sheridan.
Oh snap!
Oh my god.
You're
It's
right,
working
Sheridan.
here.
Yes, there is no relationship. If I have no foreign key, I have no relationship.
What just happened?
I feel smart. I am so excited. You all don't even know it.
I'm excited.
So if you have no foreign key, you don't have a relationship because I don't know what teacher's teaching the course, and I don't know what course my teachers are teaching. Right? I don't have any information between the links, the connections between the two. Right? So somewhere in here, I have to have a foreign key, right? But I can't do it. I can't create a many-to-many by putting it on neither. I can't create a many-many by putting it on both. And I can't create a many-to-many by putting it on one or the other, because putting it one on the other gives me a one-to-many or a many-to-one relationship, right? So can you see how the structure doesn't allow many-to-many relationships?
Yeah.
Okay. So in SQL, in relational databases, there is no such thing as a many-to-many relationship. You can't really directly implement it. Okay. So we have to use a bit of a hack, a bit of a cheat. Because I can't implement many-to-many relationships, I have to take that many-to-many relationship and turn it into relationships that I can implement, right? I need to take it from a relationship that I cannot implement to a relationship that I can implement. Okay, so what kind of relationship have I implemented here? I've implemented a one-to-many, right?
Yeah.
So instead of implementing a many-to-many relationship directly, what we do is we introduce something called a bridge table, and we have two one-to-many relationships on either side of it. Okay, so the way I model this, if I'm going between courses and students, which was a many-to-many relationship, is I have to introduce another entity between them. Okay, so I introduce this idea of a course student, which tracks the students that are in my course, or the courses that my students are in, right? So this table tracks that many-to-many relationship, right? So we introduce this bridge table. So this bridge table needs to have two columns at least. It can have more than two, but it needs to have at least these two. So because it's between the course and the student, it needs a course ID and a student ID. See that where I pulled the primary keys from the two different tables and slapped them together?
So does course student have a primary key, or is it just going to run off foreign keys?
So there's two ways to implement this, and it depends on what your requirements are. So it may have another ID. It may have another primary key. Remember, but remember, a primary key can be more than one column. Right?
Oh, yeah.
So there's two different ways to implement this bridge table in terms of its primary key. I can add an ID column to it and use that, or I can say, let's use a composite key. Let's use the course and the student, put that together. That is our primary key. Does that make sense?
Yeah.
So in this case, that actually works. I can say that my course ID plus my student ID is the primary key for that table in the middle. Okay, and that works because my student can't hold multiple seats within a course, right?
Yeah.
I can't have that same student having 3 seats in the same course, right? And I can't have that student being in the course multiple times, right? I don't want to have the student be in AWD 1111 3 different times, right? I don't want him to pay for the course 3 times. I just wanted to pay for the course once and only take up 1 seat, right? So in this case, that makes sense for it to be a primary key, for that to use a composite key here. Now, sometimes there are cases where you don't want that to be, right? You may want to put the item into the other thing more than one time, right? So let's say I'm buying things at a store and I've got my orders on one side, right? And I've got my orders on one side and I've got my products, right? So my customers are making orders and they're putting products into their cart. Can a customer put a product into their cart more than once?
Yes.
Yes.
Potentially, yeah. Right? So maybe I could order, if I'm going to my cowboy boot store, maybe I order 3 top hats or 3 black belt buckles, right? I could do that, right? And that would be a case where if I want to support that, then I would need to say, let's put an ID column in addition on this bridge table. Now, what's another way that I could handle that exact example where I'm trying to put 3 boots into 3 of the same boots into my order? What's another way I could do that rather than doing what I said, having 3 different records in the database? What do you usually see in your shopping cart if you have 3 of the same item?
Like
Quantity 3.
The quantity, right? So if I added a quantity column to that bridge, right, then I wouldn't need to, then that could be unique. Does that make sense?
Yeah.
So oftentimes there's more than one way to solve the same problem. And it depends on your specific requirements. So in a shopping cart case, it's usually better to go ahead and keep those 2 as your primary key, but then say, well, let's introduce a quantity onto here, and we'll just, every time the user adds something to the shopping cart, we'll do 1 of 2 things. We'll say, is it in the shopping cart? If it's not, then we add it. But if it is already in the shopping cart, then I need to go update the quantity. So I can do it that way, and that may make some of my logic simple, but then it also makes my logic to add things to the cart means it needs another step, right? So the way you design the database can oftentimes affect how you have to write the code and the complexity of the code therein.
I got a question. So the bridge in the middle,
Yes.
we're going to have 2 foreign keys there. It would be the product and the customer, right? And then there's one
Product
quantity.
in the order. The product in the order.
Product in order. Okay.
But you're saying?
I was just thinking customer, product in order. All right. So it'll be 2 foreign keys though.
Yeah.
And then a third one, quantity, which would be just another class or another entity.
Just another property, not another entity. The quantity would just be another attribute. It would be a circle, not a square.
Okay. Yeah, I see.
Okay, because your quantity is not an object, it's just a number.
Okay, I think you said primary key earlier.
Mm-hmm.
You you could do either one, right?
Right.
Or
Well, you can't use one of these by themselves. You can't use the course ID by itself, and you can't use the student ID by itself.
Oh yeah, it's composite, right?
Right. You can use the two together, but not separately. Paul, your mic's open, by the way. So I can use the two together, but not separately. If I use one of them by themselves, just the course ID as the primary key, or just the student ID by itself as the primary key, I would end up making this relationship one to many instead of many to many. If I choose...
Oh, right, I got that.
Right.
I got that part of it. It's just that I got confused on whether they're foreign or primary keys.
Yeah.
Because I think you said primary earlier.
Well, these would be here it's a primary key on the left, the course ID. Here it's a primary key here on the right. But in the middle here, these are both foreign keys. But
Okay.
same thing in this case. In this case, these columns in the middle can be both primary keys and foreign keys. Does that make sense? They can actually be both.
Yeah, but it wouldn't add value to identify them as such. It's just something that's optional, but it should be one or the other.
No, it can be both. I'm saying these at least have to be foreign keys, but they may or may not be your primary key.
Okay, I guess it'll come out later.
Yeah.
At least I need to know for now is the foreign key part of it.
So the next thing to kind of mention when we're talking about our databases, we're also oftentimes want to add indexes to our databases, and those indexes will really speed up our database queries. Oftentimes, anytime we have either a unique value, a value that's got a unique constraint, or you've got a foreign key, oftentimes you want to add an index with it. Now, it's worth noting that you don't denote indexes on your ERDs, because your ERDs are just kind of a diagram of the overarching structure. So indexes is a detail that we add when we actually build the schema. So your database should always have some indexes, but those indexes that you add really depends on how you're using the database. The point of those indexes is to speed up your queries, especially when you're going from one table to another. If you don't have indexes, what happens is that it has to go through your entire table from top to bottom. It has to say, look at all of the rows in the table. So let's say I'm looking for just the products, right, that have the category of belt, right? I don't want to look through all of the products in my database. I just want to go look at the belts or the belt buckles, right? So that would be a case where I want to add an index on the category so I can quickly get to just the things that have the category that I want. With me?
Yes.
Okay.
Yeah.
So we'll want to make sure that when we design the database, we'll do an example here in a minute. I want to look at that cowboy boots store. One of the things we need to remember when we go to actually build the SQL is not to forget to add some indexes to it. Okay, so I think that is the end of my slides here. Okay, so that 225. So I sent everybody a link over Discord to a Jamboard, so you should have a link to that. So I'm going to split everybody up into 4 groups so we can do this exercise as kind of a group exercise. I think that'll be kind of a good fit. Cool. Okay. So we've got everybody moved around. Okay, so what I want to do is kind of do this as a group exercise. So there should be at most 3 people in your group, because we got 11 people here. One of the groups only has 2. What I want you to do is create, this is Jamboard, anybody in your team can draw on it. What I want you to do is create an ERD for the Cowboy Boots website that we've kind of been talking about for the past few weeks. So what I want you to do first is go through, kind of clear off your slide if you have some stuff on it already, and put in the entities and the relationships between those entities, for what you might need. Okay. So I've also created some voice channels down in Discord. So if you would go into those, for your team. I think I'm going to pull everybody up to the main classroom now. So if you would rejoin the classroom. Any questions before we go back up to the classroom?
Nope. Are we just waiting on everyone else?
They're waiting for you.
I told you, Sheridan.
I'll see you there in a minute. Welcome back.
All right.
So how does everybody feel about their diagramming skills now?
I feel like mine can improve.
A little better.
Okay. There's definitely a lot to think about, right? In terms of, oftentimes the thing to make sure that you do is get into your user's mind and see, what are going to be the important things about how they're going to use the system and what's important to them. Because it's not so much a technical exercise often as it is a figuring out what the user wants exercise, right?
Yeah.
So let's go through just looking at what everybody did. So we've got this one. So we've got some people came up. You got product, order product, customer. It looks pretty good. And so you got that. I think what I mentioned is you've got kind of the address. One of the things you have here is you have the address kind of being duplicated on every order and things. So sometimes it's worth, you'll see, kind of maybe pull it out as a separate table. So there's that. And who was this? This was Ben and Ben, Muhammad, and who else was in, or who was in?
Troy.
Okay, so well done. I don't know if you can hear me clapping from this side, but
Yeah,
then we have option 2. It looks like people are still drawing faces. So you guys did a smart thing, which is you said on the product, well, let's make some other tables. So you've got a materials table, a colors table, a size table, and a category table. The benefit of doing that, and I think I already talked with you guys on that, is that you're now saying that it can only be one of several values. If you can have it just as that, and then it's actually a really simple system. In general, your systems are simpler the fewer tables you have, but this gives you a way to make sure that there's only for instance, the type can't just be anything, but it can only be the material can only be certain values, the color can only be certain values, size can be certain values, in category. So sometimes you want to do that to say, limit it to who can actually put in, what values you can actually put in. So this gives kind of constraints. We've got option 3. So what team 3 did. So you've got products, product order. You've got an address in between here, and it looks like you broke that up as 2 tables. So you've got a customer address and then an address. So you're kind of saying, who does the address belong to potentially. So this is good. And then we've got team 4s. So yeah, everybody's good.
Hey, those don't look like boots.
So
That's a kit.
any questions? You've seen a few different ways to do it.
I don't know if it's necessarily a question, but bridge tables, I don't think I understand them particularly well.
Okay. Well, the basic idea is anytime you have a many-to-many relationship, you just add a table in between. That's the kind of the gist.
I think the confusing part for me is kind of what that table then represents. So it's like a combination of the two, but I feel like it's
It
more
basically.
to one.
So remember you remember I put the diamonds on, and they represent relationships.
Yeah.
Well, this table in the middle, which is a bridge table, and you can actually see how many tables is it connected to. 1, 2, and 3, right?
Yeah.
So it's actually a 3-way bridge. It represents a relationship. This table represents a relationship between a shopping cart, an order, and a product. Does that make sense?
So it's just like a
I like ours.
communication.
We've added improvements.
I think that ours is just the most artistic. Everyone else is just like very
Yeah, but ours
much.
has a picture of Mr. G, so
Why do you still have that?
I don't know, honestly. I think I thought I deleted it.
So,
Everyone's looks so nice, and we're just like scribbles all over the place.
so you guys all have your your diagrams, right? So the thing to do next would probably be to take that and turn it into SQL, right?
Yeah.
Okay. So it's already 4:00 here. So, I think what I'm going to have you do, is I'm going to have you in your 4 teams, go ahead and take what you have as a diagram and try to turn it individually into SQL, right? Try to take what you have in your diagram and create those tables.